Hello, welcome to AQA demola, and today's lesson we're going to be talking about empirical formula. I think it's a really interesting topic, but it is a bit hard to wrap your head around, so we're going to get straight into it and hopefully get this to be learned very well. Okay, so to start off with, there's just two type of formula that we need to be happy with and aware of, right? So the first one that we're going to talk about is our molecular formula. Now, simple definition, this is the number and type of atoms in each element in a compound. So the number of each type of atom in each element in a compound, right? Let's look at it. So for example, I've drawn out a glucose molecule here. And if you took your time to count up each of the atoms of each element in this glucose molecule, you'll find that there are 6 carbons, 12 hydrogens, and 6 oxygens, which is why our molecular formula is going to be, again, we look to the periodic table so we can find the symbols, but C6H12O6. So that's how we do molecular formula. Now, empirical formula, guys, this definition is big marks in the exam, right? Big marks in the exam for this definition. They ask it a lot. So remember, your empirical formula is the simplest whole number ratio of atoms of each element in a compound. Yeah, present in a compound. Remember that definition for empirical formula because it's important. So like, for example, C6H12O6. Well, if I think about highest common factor, let's think to maths. The highest common factor between 6 and 12 is going to be 3, right? So we can divide everything by 3. So divide by 3, and then we're going to get, sorry, my apologies, it's 6. A bit of a mistake that is 6. But you can see here, divide everything by 6, and you're going to get CH2O. Cool. Now, that number, so we said that 6 is going to be n. Yeah, 6 is equal to n. So we'll write that here. So 6 equals n. So n multiplied by the empirical formula gets you a molecular formula. So that's how you work back. And just another mistake that I made there. N is not 3, n is 6. Yeah. But I hope that concept makes sense. So the empirical formula is just the simplest whole number ratio of the atoms of each element present in the compound. We're going to use our highest common factor, and that's how we're going to find it. Okay. Okay, so there are 2 ways that we can solve these questions, right? By percentage composition or by mass composition. But we're going to begin with percentage. So if we look at our question here, it says a compound is found to contain 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. First things first, when you get this question, just make sure that that will all add up to 100. Yeah, you don't want to make a mistake where these percentages don't add up to 100. In this case, they do. Yeah? Okay. So what we're going to do is we're going to write out those percentages, yeah? So sodium, we just got this symbol there, 36.5. Sulfur was 25.4. And oxygen was 38.1. Cool. So we've written out the percentages. And now we're going to look at the periodic table so we can find our mass numbers. So let's have a look here. Sodium, 23.0. Oh, too big. So sodium, we said is 23.0. Don't worry about that. We're also looking for sulfur. Found sulfur here, 32.1. And we're also looking for oxygen, which is 16. Yeah? So we found all of the elements on a periodic table so that we can continue this question. So sodium being 23.0, we're going to divide everything by the atomic number, 32.1 here and 16.0 here. Okay. So get your calculators out, and what you're going to find is these answers. So for sodium, we're going to have 1.587. I've rounded, but I would implore you in the exam to not round. Right? I would not round at this stage. But those are going to be your values when you do those calculations. Okay. The next step, really important, you divide by smallest value. So if we're dividing by the smallest value, right, that's going to be this guy here, right, the 0.791. Get rid of that. So we're dividing everything by 0.791. Divided by 0.791 and divide by 0.791. Cool. What does that give you? Well, here it's going to give you 2.01. And then we're going to express this as a ratio now. Right, to 3.01. Now, I look at 2.01, I look at 3.01. I'm going to say it's close enough, guys. It's close enough to being 2 and 3. So we're just going to kind of ignore this. Yeah? That wasn't meant to go to that. But yeah, we're going to kind of just ignore it, and we're just going to leave it as 2 and 3. So now we have our ratio of sodium to sulfur to oxygen in the compound. So that will help us to our empirical formula as Na2, just 1 sulfur, and then 3 oxygens. I hope that worked example makes sense. as to how we're going to find the empirical formula. And this compound, if they ask you to name it, it's called sodium sulfites. Okay, so fortunately for us, when we're doing maths as well, we are literally doing the same thing, same process. But this time we've added the second part to the question, so let's read it. A compound contains 3.6 grams of carbon, 0.9 grams of hydrogen, and 4.8 grams of oxygen. Its relative molecular mass is 60. What is the empirical formula and what is its molecular formula? So we've added something on, yeah? But again, we're going to go through the same process that we did before. So carbon is 3.6, hydrogen is 0.9, and oxygen is 4.8. Let's go to the periodic table, find what the numbers are. So we did have hydrogen. Hydrogen is 1, right? We had carbon, 12, and we had oxygen, 16, yeah? So now that we've got that, again, we're going to divide these values, the mass, by the molar mass. We'll get the number of moles, right? So divide that by 12.0, divide this by 1.0, divide this by 16.0. Cool. Now, we've got that. What are we going to do with it? Okay. We need to get the answers, right? This is 0.30, this is 0.90, and this is 0.30. So what did we say? Divide it by the smallest number. Divide it by the smallest number of moles, which we can identify as 0.30. So everything gets divided by 0.30. And then we're going to get a ratio of 1:3:1. Yeah? Fantastic. And then that's going to help us to get our empirical formula. So the empirical formula is then going to be CH3O. Hope that part makes sense, because now we need to get to the next part where we're finding the molecular formula. Now, like we said, we're looking for that N, that multiplier that we need to get from empirical to your molecular. So what we can do, actually, is we can work out what the mass of the empirical formula is, right? How are we going to do that? So the atomic mass of carbon, multiplied by the number of carbon atoms, added on to the molecular mass of hydrogen, multiplied by the number of hydrogen atoms, plus the atomic mass of oxygen, multiplied by the number of oxygen. And what you're going to end up is 31. Yeah? Cool. What we can then do is 60 divided by 31, because 60 was our molecular mass of the whole compound when we look at the question. We do that, we get 1.94. And from my perspective, this is close enough to 2 for us to just say that our value for N is going to be 2. Right? So, if you think about it like this, CH3O, and we've got 2 lots of it, that means that our molecular mass, or molecular formula, is C2H6O2. I hope that makes sense in terms of how do we go about approaching this question when we've added on this extra bit. Okay, so now we've got 3 questions to try relating to this topic. One of them you're using the percentage composition. Another one, I want to use percentage composition and you're doing empirical and molecular. The other one, you're using the mass and you're going to do empirical and molecular as well. So take a moment, pause the video and try out these questions. Here are your answers. So if you look at question 1, again, you're using those percentage compositions, right? So you can find the periodic table. Carbon is 12, hydrogen is 1, oxygen is 16. You do the exact same process that we did before. This time you're going to get the empirical formula as C2H6O. Now, again, we've used some rounding, yeah? You can see the symbol, approximate. So we're using an approximation here. But approximately 2, approximately 6, approximately 1. You shouldn't have got those as exact values. Or maybe 1 you would have, but yeah. That's how we do that question. Now, again, same process again. Something that we didn't mention, actually. You see this, 3.3. Oh, no, sorry, we did mention it. But you can see again, ratio. Yeah? You can see the ratio that we have. 1:2:1. Cool. You would have gotten the empirical molecular mass here as 30. And if the molecular mass is 180, we know that the multiplier is 6. And that's why we're going to do that. You're going to get a nice glucose molecule. Final question. Lithium and chlorine. Now we're going a bit more abstract, yeah? We're not focusing on the ones that we normally see, right? But it's exactly the same process. Exactly the same process. So just be happy with that as well. Because if you follow the same process, you should get the answer. And like we said, 1.21, it's not exact,
but it rounds to 1. I'm going to be happy with that. Okay, and now to round it all off, we're going to look at our A-star tips. What do I think we should do in this topic? Guys, use the periodic table, please. Literally, it's there on your data sheet. It's there for you to use to help you. Just use it. Look at the mass numbers that they're going to want you to use. If they don't want you to use the ones in the periodic table, they will specify it in the question. Cool. Don't round early as well. Guys, you got to love that answer button on your calculator. You've got to love the answer button on your calculator. Please use it because it will help you out and it will mean that you don't make silly mistakes because you rounded too early. Cool. When you have the ratio, only round if very close to the nearest whole number. So for example, 0.5, 0.67, even like 0.33, a third, 2/3 and a half. Guys, you can get that in the question and that can be part of you doing the ratio. So like, I don't know how to describe it, like for some of the questions, you'll get 1 to 0.33 or to 1.33 or something. Yeah. So this 1 to 1.33, that's completely valid because I'll just change that to 1 and then 4/3. And then when you times it by 3, you have a 3:4 ratio. So that is also possible. Just be aware of that. And also, I'd say use 1 dp for the atomic masses of elements. I believe all the ones in the periodic table are to 1 decimal place, from the OCR data sheet at least. So just go with that. What do you not do? Guys, a lot of people panic because they see a lot of decimals, okay? Don't panic if there's decimals. These questions, and honestly a lot of chemistry questions, yeah, they are not nice, the examiners. They will have a lot of decimals, so don't really panic too much. It doesn't necessarily mean you've got the question wrong. And also, another thing that people lose marks on, please do not do this. If it asks for the molecular mass, you've got to do that on top of this, yeah? Because you can do the calculation, get a couple marks there, but if you don't then go to get your final answer, you also won't gain marks for that. And that's the more easy part of the question. So make sure not to miss that part out. Okay, so thank you for watching. I believe we are done here. So any questions, leave a comment below. Please like the video, subscribe, and I'll see you in the next one. Bye for now.